When adding fractions, we must look at how many pieces the whole is divided into. Both of these are divided into 5 pieces. So if I show 2/5, here's my whole. And if I show 2/5 and shade that, 1, 2 of the 5 is what I have. And then I'm going to add to that 1/5. So again, my whole is divided into 5 pieces. And I want 1 of the 5. Since they are the same size a piece, I can see visually that I have 3 of the 5 pieces. Notice 2 plus 1 is 3, and I keep my denominator. My piece size does not change. It still stays divided into 5 pieces. If I take a look at the next diagram, 1/2 plus 1/3, those are different size pieces. So if I was to look at them visually, 1/2, and we'll shade that top region as 1/2, and 1/3. 1/3 is this stripe headed this way. Now we can see that those are not the same size pieces, so I can't get a total until I make them the same size. So what I'm going to do is I'm going to take my 1/2 and I'm going to divide it lengthwise into 3 pieces, and now I've changed that into being a new fraction, which is 3/6. Now we talked about equivalent fractions. I have the whole divided into smaller pieces, but I have more of them. 1/2 is the same as 3/6. If I take my second fraction and divide it in half, now I have 6 pieces for both, and the 1/3 shows that it turns into 2/6. Combining these two fractions, they are equivalent to the ones listed directly above. Adding them, I get 5 of the 6 pieces. I get 5 of the 6 pieces for a total. So without doing a diagram or looking at a diagram, what we're trying to do is make these 2 divisions of my whole be the same size. So what we're looking for is the least common multiple. So looking at 6, multiples of 6 are 6, 12, 18. Multiples of 3 are 3, 6, 9. The least common, you can see, is 6. So what I need to do is change these 2 fractions to have that common multiple. 1/6 has it. 2/3, I'm going to change that fraction, 2/3, into having a 6 in the denominator. Now how can I do that? Well, if I multiply 3 times 2, I get 6. I must do the same to the numerator, multiplying it by 2, and 2 times 2 is 4. So adding these, I would get 5, 6. Now the reason I can multiply 2/3 by 2 over 2, 2 over 2 is equivalent to 1. So what I've multiplied 2/3 by is 1. 2/3 times 1 is 2/3. I've just changed the 1 to be a 2 over 2. I can use any equivalency to 1, and we'll see that in the next problem. Looking at 2 and 5 and their multiples, 5 would be 5, 10, 15, and so forth. See, our common would be 10. So my 1/2 and my 2/5 are going to change slightly. Now I like to write the fractions in a vertical column, so I can change them just moving left to right. I'm going to make this value be a 10, so I multiplied by 5. So I must do the same in the numerator. 5 divided by 5 is 1. So I really haven't changed the 1/2. I've just made it a new fraction, 5/10, although it represents the same amount. Changing the bottom, I'm going to multiply each of these by 2 over 2, which is again 1, 4/10. Combining 5/10 and 4/10, I get 9/10. Notice again, the size of 10 does not change. It's just how many of those am I going to have. Subtraction is just like addition. We still need to have the pieces in our whole be the same size. Looking at 5 and 3 and finding their least common multiple, that would be 15. So I'm going to multiply 5 by 3, therefore I multiply 4 by 3 because 3 over 3 is 1. 4 times 3 is 12. Those 2 fractions are equivalent. 4/5 is equivalent to 12/15. Second fraction, multiply this by 5, both numerator and denominator. 2 times 5 is 10. I have 12 of the 15 pieces. I'm taking 10 of those 15 pieces away. I'm left with 2 of the 15 pieces. And the last problem, 3/8 minus 2/7. Again, I like to write them vertically instead of horizontally. Looking at my multiplication table, between 8 and 7, the common denominator is going to be 56, and it just happens that I'm going to take 8 times 7 and 7 times 8. 7 over 7 is 1, so again I'm taking 3/8 and really multiplying it by a 1. So it's not changing the value, it's giving me or creating me two equivalent fractions. The second fraction, 7 times 8 is 56. 2 times 8 is 16. I'm now subtracting those. 21, take away 16, leaves me 5 of the 56 pieces remaining.